Hey there! Today, we're going to crack open the playbook on one of the internet's oldest and most clever threats, the DDoS attack. And we're not just scratching the surface, we're doing a deep dive into one specific and frankly genius type of attack called the SYN flood. So, to really get a handle on this, you first need to understand something called asymmetric warfare. It's a simple idea, really. In the digital world, you don't need a huge army to take down a giant. A very small group of attackers using a network of infected computers called a botnet can launch an attack so massive it can knock even the biggest websites offline. It's all about a small force having a huge impact.
All right, here's how we're going to break this down. First, we'll map out the battlefield itself. Then, we're going to look at the attacker's playbook, how they actually pull this off. After that, we'll flip the script and look at the defender's brilliant countermoves. And finally, we'll talk about the big picture, how you build a system that's truly resilient to this stuff.
Okay, so first things first. Let's get on the same page and really understand the landscape where these digital battles take place. A distributed denial of service, or DDoS attack, is pretty much exactly what it sounds like. Distributed means the attack traffic comes from everywhere at once, not just one place. And denial of service? Well, that's the whole point, to make a website or an app totally useless for the people who actually want to use it. The core strategy is just to overwhelm the target until it just gives up. Now, this is where it gets really interesting. Let's put on our black hats for a minute and think like an attacker. The SYN flood is so slick because it's not just about brute force. It's about taking the internet's own rules, its own politeness, and turning it into a weapon. See, normally when your computer wants to connect to a server, it performs a polite three-step handshake. It's kind of like sending a letter. First, your computer sends a little packet called a SYN, which basically says, hey, I'd like to connect. The server gets it and politely replies with a SYN ACK, saying, awesome, I got your message and I'm ready for you. The connection only really starts when your computer sends one last packet, the ACK, to say, great, I heard you back, let's talk. It's a system built on trust. And that trust is exactly what the attacker breaks. On the left, you see that normal, happy handshake completing. But on the right, that's the attack. The attacker just floods the server with that first hello, that SYN packet, usually from thousands of fake addresses. The server, trying to be helpful, responds to every single one and sets aside a little bit of memory, waiting for that final confirmation, an AK that's never gonna come. Think of it like a prankster calling a restaurant 1,000 times to make fake reservations. Pretty soon, all the tables are reserved, the restaurant thinks it's full, and no real customers can get a seat. The server is just left hanging with all these half-open connections until it completely runs out of resources.
And get this, we're not talking about some super complex Hollywood hacker kind of code. This is a simple Python script that can do the job. It just sets a target, makes up a bunch of random IP addresses to cover its tracks, and then fires off SYN packets in a never-ending loop. Now, obviously, and this is super important, this is for educational purposes only. Doing this for real is absolutely illegal, but it just goes to show you how simple, how accessible these attack tools can be.
Okay, so the attack is simple, it's powerful, and it's easy to launch. That sounds pretty bad, right? So how on earth do you defend against it? Let's switch hats to the blue team, the defenders, and look at their strategies, which, trust me, are just as clever as the attack. The first thing to know is that good defense is never just one single wall. It's all about layers, like a funnel. The first and widest layer is scrubbing, which is where giant services filter out obviously bad traffic before it even gets close to you. Then you have edge optimization, which involves smarter tricks right at the front door. And finally, the last line of defense is architecture resilience, making sure your system is just built tough from the inside out. And one of the most brilliant tricks at the edge is something called SYN cookies. Here's the genius of it. Remember how the server's vulnerability was that it set aside memory right away? Well, with SYN cookies, the server doesn't do that. Instead, when it gets a hello, it sends back its reply with a specially crafted unique number, the cookie, and then it immediately forgets about the request. It uses zero memory. If the request was real, the legitimate user's computer will automatically send that cookie right back. Only when the server sees that valid cookie return does it say, okay, you're real, and it finally allocates the memory to start the conversation. It's a beautiful solution that makes the client prove they're legit before the server risks any of its precious resources. So defending in the moment is one thing, but the real long-term win is building systems that are just ready for this kind of thing from the get-go. This is all about shifting from just reacting to a crisis to a permanent state of readiness. So let's walk through what this looks like in the real world. Here's a typical attack timeline. Everything's running normally at the baseline. Then boom, the attack hits.
Pretty quickly, you get service disruption. The website goes down. But then, the mitigation kicks in. An engineer flips the switch to enable SYN cookies. And look what happens. Almost instantly, the service recovers. The attack might still be hammering away, but it doesn't matter, because the system is now smart enough to ignore it.
But the fight isn't over just because the alerts stop. The real work happens afterward, with a post-attack debrief. You have to ask the tough questions. Did our alerts go off fast enough? Did our systems scale up like they were supposed to? And the big one, why wasn't a defense like SYN cookies just turned on by default? It's this learning process that turns a one-time disaster into a stronger system for the future.
And that really brings us to the most important takeaway of all. As the source material says, these attacks are always changing, always evolving. You can't just plug one hole. The only way to win in the long run is to build a highly resilient service architecture from the ground up.
This whole playbook, from the attacker's simple trick to the defender's clever response, it's this constant game of cat and mouse. And it really leaves us with a big question, not just for websites, but for all of our digital lives. In a world where the threats are always changing, is your fortress just built to defend, or is it truly built to be resilient?